Okay, let's look at another example. Scores from IQ tests are considered to come from a normal population with the mean of 100 and a standard deviation of 15, or variance of 15 square, which would be 225. So how we do represent that? We say X is normally distributed, mean is equal to 100, and sigma is equal to 15. Suppose it has been suggested that psychology students have a higher IQ than the rest of the population. So how can we test this theory? And what would be our parameter of interest? Parameter of interest, when we say define the parameter of interest, is you say that let mu be the average IQ score for psychology students. All right? Now, so we say mu is the average IQ score of all psychology students. Now, null hypothesis. We say that IQ scores have a mean of 100. We claim that our psychology students are cleverer. They have got a higher IQ. Yeah? So, what would be the null hypothesis? There is no difference between the IQ score of psychology students and the general population. What is the general population IQ score? Mean is 100. Yeah? So what do we write here? We can write that H naught mu is equal to 100. What would be the alternative hypothesis? We said psychology students are cleverer. They have got higher IQ. Alternative hypothesis is mu is greater than 100. All right? Now, why have we chosen the null and alternative hypothesis this way? This is the way we do. Null hypothesis, no difference. And alternative hypothesis, what we want to prove. All right? Now, unless we have evidence to the contrary, we always believe that psychology students' IQ score is the same as the general population. When we have got enough evidence that the psychology students have got a higher IQ score, then we reject what we believe. We can't take every single psychology student, do the test, get the score, and then find the evidence. So what we do, we take a sample of psychology students, make them to do the test, and then get the sample mean. And then we draw conclusion about the whole psychology students. Now, we know that the IQ score in general population has a mean of 100, a standard deviation of 15. Now, if we take a sample of size 25 from this population, all right? So, sample of size 25, n is equal to 25. What would be the comparison distribution? First thing. Now, comparison distribution, we talk about X bar. X bar has normal distribution. The mean of the X bars is the same as the population mean of the individuals. Mu is equal to 100. But the standard deviation of the X bars was 15 and divided by a square root of 25. Actually, I better write this one. Sigma of X bar is equal to sigma, which is 15, divided by square root of sample size, 25. All right? So, the X bar has got, this is the comparison distribution. Normal distribution, 103. All right? That would be our comparison distribution. And you can see here, this is the distribution of the population of the individuals, and this is the distribution of the samples of size 25. Now we need to have a cutoff score, a threshold value. And we say that if we found the mean of our observed mean of our sample gets more than this threshold, we say we have got enough evidence to reject the null and say psychology students are cleverer. The critical value or cutoff score, if I'm working with the Z score, then my Z score is Z 1.64 for 5% significance level. All right? So that can be my cutoff score. Rejection region would be any area. If I'm dealing with the standard normal, I say if any value I get which is greater than 1.645, any value in here will be will give me evidence that I say psychology students are cleverer. Now the cutoff score is 1.645. I can change that to my raw score. How do I do that? I say 1.645 or 64 multiplied by my sigma was 3, and I add mean to that, and that will give me 105. 104.95. We call it 105. Yeah? So, my cutoff score here would be 105. If I get any IQ score greater than 105, I have got enough evidence to reject the null hypothesis. So that is my cutoff score at 5% significance level. This area under the curve is 5%. Let's say that I've taken a sample and of size 25, and these are the IQ score of the students I have taken, psychology students. I get my X bar, I get a value of 107. So what will we decide? Cutoff score 105. This falls into my rejection region. Yeah. So my cutoff score was 105 and my observed value is 107 here. Yeah. So this area is my rejection region. So I say that because the observed X bar falls into my rejection region, I have got enough evidence to reject the null hypothesis. Now, the probability of observing what you have observed, or even more extreme, in the direction of alternative hypothesis is called p-value. And this is the p-value, and p-value is given by SPSS. So that is another example for this week. Thank you.